circling the Earth with a period of 5 hours. So every 5 hours, it's going to circulate the Earth for one cycle.
You might need another pen.
Huh?
You need another marker.
No, here, this one is fine. I did it twice. So here the Earth. And then from class, did you know this formula? You got this formula?
That's the period, right?
Yeah, that's the period of the satellite.
I thought it was T squared over.
The time, I mean, here you got 5 hours is equal to this. I can show you how you can get this. Let me see. So the force is equal to G m r squared, and it's equal to v squared r, right? Because it's times small m. That's ma, right? And you know the velocity is 2 pi r divided by t. So if you plug in this 2 pi r divided by t here, you got 4 pi square r square t square r times m is equal to this, right? And then if you want to calculate, and let's simplify this, will be g. You can cancel this m, right? You can cancel this r, right? It's gm divided by r squared is equal to 4 pi squared times r divided by t squared. So if we want to calculate t squared, is 4 pi squared times r cubed, because you move this here, right? And divided by gm. So what you need to do is take a square root of the whole thing, which will be the same as this one. But this time we can. So the first thing you need to get this relationship, okay? Because what we want to do is we want to get the r. What's the r? For a given period, the r is fixed, right? If the sunlight has a period of 5 hours, it's gonna be in the same height, right? So from this you can calculate the r. R will be t squared gm divided by 4 pi squared square root cube square root the cube root, right? And then you need to plug in the numbers gm t squared, and you use a calculator to do that. And then you got 1.49 times 10 to the 7th meter. So the height from the center of the Earth to the satellite is 1.49 times 10 to the 7th. And then from here, we know the force. Because the question is asking you how much, the question is asking you what's the gravitational force. So the force will be V squared R times M, right? Which is 4 pi squared times R times M divided by T squared. So 4 pi squared, the R we just got 1.49 times 10 to the 7th. And the mass for the satellite is 20. T is 5 hours, but remember to convert into seconds. 5 times 3,600 square. Okay, so you can use your calculator. In the end, you will get 36.27 Newton. So the answer will be C. Okay.
So the two formulas that I need to just remember is the T squared equals to 4 pi squared times R cubed over GM.
It's hard.
And find a relationship.
It's hard. Maybe it's hard for you to remember, but if you know the relationship is the force is Gm R squared is equal to R times M. That's the formula, because you know here is the Earth, here's the satellite. The force, you know, by the formula, you know this, right? And you know it's constant circular movement. So it's gonna be ma. The a will be v squared divided by r, right? So from these, you can convert way by 2 pi r divided by t. So if you plug in those numbers, you will get the relationship between T and R. But if you remember, it will be great. It will be faster for you to calculate. So, and number 3, a spaceship of mass m. It circles a planet mass big M. And the radius is R. So, and right now, we want to push the spaceship into a new orbit with 3r, the radius. So the question is asking you what is how much energy you need to give to the spaceship to make it to change the orbit. Okay. So what you need to do is to calculate this final energy and calculate the initial energy, right? And then use the final energy and minus the initial energy will be how much energy you need to transfer this spaceship